Here's the answer for day one, problem one. Simplify as much as possible. We have 25 to the negative 3 halves power. Let's deal with the different pieces of that exponent. First of all, the negative sign in the exponent creates a reciprocal. So we can write 1 over 25 to the positive 3 halves power. Next, let's use the denominator of that exponent as a root. So because the denominator is a 2, we can take a square root. That allows us to write 1 over 5 to the third power. The square root of 25 makes 5. Finally, we'll deal with the 3 in the exponent. 5 to the third power is 125. So 1 over 125. Now, day one, problem two, factor this polynomial. First thing I'm going to look for is a greatest common factor. Is there any number other than 1 that divides into 16 and 81? There's not. Next, I'm going to look for a special pattern. This is a binomial difference, so the special pattern that I'm looking for is called a difference of squares. This is a perfect square because 4x squared times 4x squared makes this term, and this is a perfect square as well, 9 times 9. So we'll factor this using the double parenthesis pattern. This is 4x squared here and over here. And then here is positive 9, and here is negative 9. Now we need to look at each of these to see if it factors farther. This is a sum of squares. This does not factor farther if you only use rational numbers. This is another difference of squares. It can be factored with the double parentheses. So our final answer will have 4x squared plus 9, and then a double set of parentheses, 2x times 2x, and a positive 3 times a negative 3.